Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about product categorization. This topic is based on a tech blog with the title Advancing Product Categorization with Vision Language Models: The Power of Fine-Tuned Lava, written by the data science team from Faire. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved.
What is Faire, the company, and why do they need product categorization?
Faire is an online wholesale marketplace that connects independent brands with local retailers across a wide range of categories like home goods, fashion, and beauty products. It allows small businesses to source unique, hand-picked items from emerging brands, helping them stand out in their local markets. Retailers typically use Faire to discover new products, place orders, and manage inventories all in one place. But for the system to run smoothly, an essential part of Faire's operations is product categorization, meaning organizing all products into clear and searchable categories. This process is crucial because it affects how retailers find the products they want to stock, how inventories is managed, and the overall efficiency of the platform. Without proper categorization, retailers could struggle to find the right item, and Faire's marketplace could become chaotic.
That sounds important, but why is it so challenging? Isn't it just about assigning products to categories?
Great question. Well, it seems like a simple task. It is actually quite complex. Faire's inventory is vast and rapidly growing, with over 3,000 product categories options and more than 100,000 brands. Each product has its own unique features, so ensuring they are categorized correctly can be labor-intensive. There are some key challenges, includes inconsistent product data and ambiguous product descriptions. Additionally, Faire operates in multiple markets, which adds complexity in terms of language and regional differences. Overcoming these challenges is vital because if products are miscategorized, retailers have a hard time to finding them, leading to missed sales opportunities. In fact, Faire's internal staff, assisting with brand onboarding, spent about 15% of their time on product categorization, driving up operational costs in the whole process. Automating this process accurately would streamline onboarding for brands and make it easier for retailers to discover products, creating a healthier marketplace overall. Now that we've understood the business problem, let's dive into the technology side to explore potential solutions. Initially, Faire's data scientist team used the k-nearest neighbor algorithm alongside clip embeddings to tackle the challenge of the product categorization. The k-nearest neighbor algorithm is a simple yet very effective method that identifies similar products by measuring the distance between their features. These features can include various data points, such as color, shape, material, and even abstract qualities like style or theme. But just those basic feature points may not be sufficient. So this is where clip embeddings come into play. CLIP, C-L-I-P, which stands for Contrastive Language Image Pre-training, is a deep learning model developed by OpenAI in 2021. It transforms both images and text into numerical representations, or embeddings, where these numerical representations are in a shared space. By training on a large dataset of images and text, CLIP maps related image and text closer together while placing unrelated ones further apart. When combined with the k-nearest neighbor algorithm, this approach allows Faire's team to categorize products by interpreting both visual and contextual data to identify the closest product category that one product belongs. This solution was a solid starting point, and it improved product categorization by integrating visual and contextual cues. Hence, the team built an automated system around it. However, human audits revealed that around 15% of products were still miscategorized, and this requires the operation team to frequently conduct large-scale manual reviews and corrections. So, while this k-nearest neighbor CLIP model streamlined the categorization effort, the high number of manual adjustments made this process costly and time-consuming. The team dived deeper and uncovered several factors contributing to this accuracy issue. Certain product types, particularly in apparel, are naturally hard to categorize because different styles can blur those category lines, and distinctions are often very subtle. Meanwhile, inconsistent information from different product fields further complicated predictions. For example, product titles, descriptions, and images might each contain important information related to the product type, but sometimes those point toward different categories. To achieve better accuracy and efficiency, the team turned to a more advanced solution, fine-tuning vision language models directly. Vision language models are designed to understand both visual and contextual data simultaneously, allowing the model to see the image and read the text in a more integrated way. Well, clip embedding is one type of the visual language model output. Clip is trained on a general dataset and not customized for the specific datasets Faire's data team was working with. To better incorporate the unique aspects of their domain-specific data and label, the team decided not just to use clip embeddings directly, but to fine-tune a state-of-the-art vision language model with their in-house dataset. In practice, the team adopted the Lava model, an open-source vision language model known for its strong performance across various benchmarks. They fine-tuned this model using millions of product data points that had been manually audited by the operations team. And this makes the model more customized for their internal business needs. This modeling upgrade led to a significant improvement. The accuracy of the product categorization increased from around 70% with the old k-nearest neighbor model to 95% with the new vision language model. With this highly precise automated system, Faire not only reduced onboarding time for brands by 20%, but also significantly decreased the need for manual corrections. This resulted in a lower operational costs and a more efficient product categorization process. This is an impressive win for the business, driven primarily by advanced machine learning technology. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Faire tackled the challenge of product categorization. They initially used the k-nearest neighbor algorithm with clip embedding, which improved categorization but still required manual corrections. To further enhance accuracy, the team fine-tuned a vision language model using their in-house dataset, increasing the accuracy from 70% to 95%. This solution showcases how advanced machine learning can drive business efficiency. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.